Here's a solution for day 4, problem 1. Find the missing length indicated by the question mark symbol. So we want to find this length here. This is maybe described as the right side of this large triangle. Notice that within the large triangle, there's this segment drawn parallel to this segment. There's a small triangle. These are congruent to each other. So the key concept in this question is to create a proportion from corresponding parts. For example, notice how this piece here, the 25, when compared to the entire distance, the question mark, could be put into a proportion with this distance here, the 15, compared to its entire length, 24. That proportion would look like this. The 25 piece is to the question mark piece as the 15 is to the 24. So a proportion is an equation that has fractions on both sides. If you don't like having a question mark as the unknown piece, you could put a variable there, for example, x, so that you have a variable in the equation instead of a question mark. So one way to solve proportions is with cross multiplication. 15 times the question mark is equal to 25 times the 24. If we divide both sides by 15, that will get the question mark alone. So let's go 25 times 24 divided by 15. And that turns out to be 40. So we were asked to find the question mark, and we did. So what we're saying here is that 25 is to 40 as 15 is to 24. Next problem, find the value of x. Here we have a circle. The center of the circle is located. The distance all the way across through the center, called the diameter, is 30 units. We have a radius drawn in. Remember that the radius is going to be 15 units. It'll be half of 30. We have this other segment drawn in the circle, touching the side of the circle here and here. This is called a chord. And we have this distance from here to here as 14.1. We're asked to find this distance here, x. Do you see the right triangle inside the circle? One property of a chord, when it's crossed by a radius, is that it is bisected. This part and this part are congruent. That allows us to say that this is 14.1. The distance from here to here will be half of the diameter, which is 15. So we have a right triangle. We don't know this part right here. We could put a variable on that part. I'm not going to use x because x is located elsewhere. So how about we put the letter maybe y? The reason I'm doing this is because if we can find the value of y, we can then find the value of x. Because we know that this entire distance is 15. Whatever y is, we could subtract from 15, and that would leave us an answer for x. So let's focus in on the right triangle and use the Pythagorean Theorem, which is a squared plus b squared equals c squared. For the letter a, let's fill in our altitude, which is y. For the letter b, put in the base, 14.1. And for the letter C, put in the hypotenuse of the right triangle, which is the 15. Let's subtract 14.1 squared from the 15 squared. We will get y squared equals 26.19. And then we can solve for y by doing a square root. So y is equal to the square root of 26.19. And that is approximately 5.1. So we're not done yet. What we have figured out is that this distance right here, where we had put the letter y, is 5.1 units. The other thing we know is this entire radius is 15. So to get x, we can go 15 subtract 5.1, and that is about 9.9. So we have found the value of x.